é Gabriel Marão. Estamos abrindo o terceiro dia de nosso Congresso com uma reunião muito importante que discutirá, é um debate, serão dadas algumas apresentações, mas discutirá muito do futuro da internet das coisas, porque nós temos muita coisa boa acontecendo na internet das coisas, mas tem muitos desafios ainda a serem superados. E um deles é o de interoperabilidade, é o de identificação unívoca, que não tem uma solução ainda de consenso mundial. Nós temos aqui o Dr. Robert Kahn, que é um dos pais da internet, como a conhecemos hoje, mas também é o criador de uma solução que pode resolver boa parte dos problemas que virão a acontecer em termos de interoperabilidade. Nós temos também uma pessoa de muita experiência nessa área, o Dr. Alexander N. Tocco. Ele é diretor na União Internacional de Telecomunicações, que vem há muitos anos já tentando atacar esse problema. Essa é uma das missões da UIT, de que o mundo tem que ser conectado e conectado de uma forma correta. Então, há um trabalho muito grande deles nisso. E quem vai coordenar o debate disso hoje é o também doutor, professor Marcelo Zufo, que vai estar contando de experiências dele, desenvolvimento deles aqui. Nós temos 1h30 que, acredito eu, será muito importante para o que a gente venha a fazer nesse futuro. Marcelo, passo a palavra para você agora.
Bem, bom dia a todos. Eu só vou dar o bom dia em português. And immediately I will shift to English. It's a pleasure being here. My name is Marcelo Zufo. I'm a professor in electronics at the University of São Paulo. And at this moment, I'm coordinating some large pilots in Brazil towards deploying IoT here. And the goal of this panel is to have an open discussion with key global authorities on IoT. And this open discussion will be around how to make IoT feasible and a reality in this country. So it will be an honor to have the speech of Professor Bob Kahn, one of the fathers of internet, and more recently, the father of DOA technology, and also Dr. Alex de Tocco. So the plan is giving speech to each member in this panel, and under the Brazilian context, but considering a global perspective, how we can effectively deploy large IoT programs in this country, considering the problems that we face in the technical and the regulation side, like the problems related to interoperability, and the problems related to legacy, and the problems related to security. So to not waste more time, I will immediately pass the word to Professor Bob Kahn. And again, Professor, thank you very much for your presence here. And during the debate, I will try to describe what is going on in Brazil, despite the COVID-19 crisis. Thank you, Professor, and please, you can start.
You unmute my microphone. Can you hear me now?
Perfect.
Yes. Okay. So this is rather extemporaneous. I don't really have prepared remarks, but let me begin by saying a little bit about the similar situation we faced with the internet in the early days, how that got deployed. And I want to begin by saying that it is usually impossible to promote and deploy a technology based on the technology itself. It's almost always driven by users' perception of what the technology can do for them. So if we were trying to promote, billion volt technology for the household, nobody knows why they would want a billion volts in their household. It's much higher, but people often sell network technology based on speed, but it's what it can do for them. And if you don't see a reason for it, then you're not going to adopt it based on the technology. So in the case of the internet, we were experimenting with how to connect computers. We thought that was something that had potential, but it was not driven by a real need at the time. Had we had the coronavirus, this pandemic back in the late 1960s, 50 years ago, or early 1970s, that could have been a driver, because look how the internet is supporting even things like this panel session this morning, and how businesses are operating in remote work at home situations. But we didn't have those drivers. And if we went around to folks and said, oh, we've got this wonderful technology, it's called TCP/IP, they would say, okay, well, why should I use that? I mean, what will it do for me? And there were really no driving applications that were so unique and innovative. As a research agenda, it made a lot of sense. Universities wanted to explore how computers could work with computers and things like that. So the way it got deployed in the case of the internet was through the desire of the research community to deal with very large data sets, things like VLSI design files or image files. And none of the existing operating systems they were dealing with, for the most part, could handle them. There was a system that the universities got very interested in, that AT&T in the US had produced out of Bell Labs, called Unix. And what we did, and since we were supporting the virtual memory version of that, where I was at the time at DARPA, we had the folks at Berkeley who were building the virtual memory version of Unix to embed TCP/IP in the Unix system. And so when the research community found they had a need to manage large files, they were doing research on VLSI or images or whatever, they naturally went to access this virtual memory Unix system from Berkeley, which required an AT&T license, and they automatically got TCP/IP with it. So it was like the carrier. They just deployed it, and nobody really understood that that's what they were getting until it was all in place and they began to use it. So that's the challenge we have here. That is, the application for TCP/IP was pretty generic, and people got it without knowing that they were really getting it. Now, some of the network researchers, yes, they did, but most of the community did not. In the case of the digital object architecture, this is, as Alex mentioned, very much like TCP/IP, but at a different level. It's all about accessing the information directly. In the case of the internet, we were moving packets, and the question was, how do you conveniently get it to some machine somewhere on the planet without the user having to know where it was or how to route it and what protocols and so forth? So we made that fairly simple. But once you were at the machine, it was up to the user to navigate it with his fingers on a keyboard, or her fingers. So in this case, since you're dealing with the information itself, it behooves us to find out how to locate where the information is. We'd have to know how it's formatted and structured and all of that sort of thing. We wanted to make that much simpler. So, and the other thing that's really different about this situation is we're dealing with people's information. And in many cases, it's very sensitive information. In almost all cases, it's considered private. And there are all kinds of laws that tend to cover this. So even with the internet today, there are actually very few statistics that you can claim about it. We know some things. We know roughly how many countries have the capability. We know some notions about that people publish about IP addresses or how much of it is being used. or not available. We know occasionally things about the domain name service and how many DNS actions are being taken, but we don't know the totality of it. And we certainly don't know everything that's going on the internet today. We might know public-facing services that are offered, but even if you look at all the companies that are involved, you don't know everything those companies are doing with the internet, and nor would they want you to, and nor is it appropriate, I think, in this case. Same thing would be true here. So when you look at what is happening with the digital object stuff, I can tell you what the components are. I can tell you, some of the implementations that I'm aware of the components. I'm aware of selected uses of it. Just like in the early days of the internet, I could tell you the first, 10 sites on, let's say, the ARPANET, or the first, 100 or so on the internet. But today we can do similar things like that. Some of it people don't really necessarily want us to talk about. But there's a tremendous amount of usage, and I don't know that we'll ever know what all the usage is. It started out with usage in the library domain for linking libraries together. It was a conceptual idea, but it became real. The publishers became an early adopter of it. And most of the people that make use of that do it through some of the more standard internet protocols, because that's what they have in place. It's not the most efficient way to deal with it. It's not necessarily the most desirable way long-term to deal with it, but people make use of it given what they have at hand. They may not even know what the better ways or more effective ways are of dealing with it, and they'll learn that in time. And the more it gets embedded into applications and services that people build, the more likely it is to be widely adopted in a better form. I know that many companies are using it internally. I gave an invited lecture at an IoT conference in Geneva. I'm guessing it was around 2016 or so. At that conference, one of the large US companies got up and explained that they were using the digital object architecture internally. And when I asked for examples of the use that they've publicly disclosed, they were not willing to explain how they were using it. So it was sort of behind the covers and very private. So I think we'll never really know, except that I know that, in some countries, like in China, I was told that in 2015 alone, there were more than 300 million things identified in their, at that time, nascent Internet of Things. Probably it's a few billions a year, if not many more today. And, with the number of things that could be out there, it could be huge. People often use different terminology to describe it. In a document that was an ITU recommendation, X1255, we were talking about digital objects originally, and there was an objection from one country who felt it was more appropriate to use a different terminology, and we ended up relying on the definition from ITU of what an entity was, namely something that was in the physical world that was, or anything that was uniquely identifiable, typically not in digital form, but if it was in digital form, we ended up calling it a digital entity. Because that's all the internet can do, is deal with digits and information in digital form. So you have entities, think of them as maybe like things, but things today in the real world are often big information systems. I think I would describe it an airplane as a thing, but it's a very big information system. An autonomous vehicle is less of a car than it is a big information system on wheels that's making its own decisions and moving itself from place to place in the physical world. So, I could describe things I know of that people are implementing. As I mentioned, libraries and the publishers were the first adopter, mainly to identify the materials. But we also have examples of people using it for financial transactions. One of the early papers I wrote tried to break away from copyright-related works and show how digital objects could represent value, sort of like an early description of what today people think of as cryptocurrency. People are trying to invent new systems for dealing with it, including, for example, blockchain. But you could do all of that yourself fairly straightforwardly using the digital object architecture components. So there's an awful lot of activity in that area that I think is related. I wouldn't want to claim paternity for that, but it's just sort of what is actually happening. We know there's applications in the music industry. We know there's applications in the construction industry. We know there's applications in the supply chain industry. We know there are applications even for COVID and tracking and tracing kinds of things. So it's very widespread. I don't think you could ever get a full enumeration, but it's going on in many ways behind the surfaces, because what people are seeing is what the end utility of the application is that makes use of it. So if you were to ask me today, and it's my last comment, what use are we making of memory chips? I would just say they're everywhere, and people aren't using them because they want to be saying, I'm using a memory chip. They're using them because they're part of an application. And the same thing is likely to be true here. So let me stop there. It's probably longer than I meant to speak, but let's let Alex have his say. Thank you.
Well, Professor Khan, it's an honor being with one of the inventors of the IP protocol also. I have dozens of questions, but to be more exciting our debate, I will pass the word to Dr. Litoko, and then maybe later we can discuss some fundamental ideas behind our speech. Thank you very much. And please, Mr. Nikoto, could you start your talk? You need to activate your microphone.
Yeah. Okay. You can hear me now.
Perfect.
First of all, let me start by thanking the organizers of the 5th Brazilian IoT Congress 2020. And even though we are all scattered in different parts of the world, technology has brought us together. So again, it's one good thing to be able to say that we are again in Brazil. For me, the journey, my encounter with the DOA actually started in Brazil, and Bob knows that very well. I think it was November 2007, second Internet Governance Forum in Rio de Janeiro. That's where I first got my encounter with the DOA, and we started working with Bob from that time. Basically, we had our first agreement. I think it was in August the next year. So it has been a long journey, and there's always been Brazil part of this journey, because I met Gabriel, I think it was 2016 or 2017 in Geneva at an IoT week. And then we decided to come, to Brazil to talk about this. For us, what I'm going to try to go through is a little bit the journey, to try to give some practical aspect of what this whole thing means to us and what it means to, or what it could mean to Brazil. Some of the features of the DOA, you've already heard. One thing for us, which was a major challenge, was that there was a lot of chaos. Things were not connected. You needed to know a lot about the structure of ITU to be able to find information. And we said, can't we connect this information to other pieces of information so that if you were interested in, A, and A was related to B, you could easily get access to B. So one of our first applications of the DOA was how we can create an environment which was customized. You did not have to know the structure of the organization. All you needed to know was say, I am interested in agriculture. And we bring those things which have to do with agriculture together, including the website, including the meetings that are taking place, including information about that particular topic. That's one of the first things that we put in place. And then we realized that, well, there are quite a number of other things also. If you wanted to find out if a device was genuine, you need to link that physical object you have in your hand with quite a number of other things that create the whole concept of it being genuine. So we also had to look at concept solutions for something like combating counterfeit. And we did that for ICT devices, but then we we realized that we, as an organization, we have also products that people are counterfeiting. This is the maritime publication. So we decided to build a solution based on geo-architecture, also to combat maritime publications. More and more, we realized that there were quite a number of areas where this could be applied. And when you start talking about counterfeit, combating counterfeit ICT devices, you can also look at combating counterfeit medicines. You know, we developed concepts. We also went back and, you know, we came up with other features such as, again, how do you create a thematic search, you know, where, you know, somebody is interested in a theme and you build a search engine that is going to enable the person to drill down. You know, you can start with one topic like big data. It would show you all the other topics which are related to big data. And then you go now, you select maybe framework, big data framework, and you go further down and you find all of the things that are related to it. So it creates a customized navigation for you to be able to find information. A lot of it for us had to do with managing information, because at the end of the day, the most important thing is the information. If you look at it very carefully, even if you go back, you know, 1865 when IT was founded, it was because people wanted to transmit information across the Atlantic Ocean. And they realized that, okay, in the US, they had their own telegraphy standards. In Europe, they had their own. But they said, what if you wanted to send information across the Atlantic? Is there anybody, any organization that can bring us together and be able? So information is a very important aspect of the discussion that we're having. We have looked at applications. My responsibility is mostly in operations. So each time I'm talking about the technology, it has to be how we apply it, because at the end of the day, I have to provide solutions, things that would make life easy for the membership of the organization, of the union, of ITO. So we have applications such as ICT landscape, which would enable you, if you are interested in, let's say, 5G, you wanted to know all the relevant standards linked to 5G because you want to build, let's say, 5G infrastructure. You know, again, this concept of linking things to other things based on the, you know, fundamental principles of the geo-architecture, you know, unique persistent ID associated with a structured record, and then you can create the relationships between digital objects. So we use that to create a standards landscape. But then we came up with quite a number of new requests, which required us to go beyond this open architecture. And now we started looking at some of the so-called frontier technologies. So we have this environment which enables you to create a very advanced information management platform. But how do we link it to other things? How do we link it to something like AI or IoT? So we moved in that direction. And one of the things that we had a very interesting experience about an event that took place in one of our member states. You know, it was in Africa, in Rwanda. And we realized that there were young people who were developing solutions to address local problems. And I was invited there to be, you know, one of the, you know, those who would decide who is the winner, who has the best concept solution. And we looked at those solutions. We realized that, you know, these things were really things that would apply in a local environment, but also have a global scope. So we came up with the idea that we need to try to create an environment where those who have ideas would be able to bring their ideas, and then we'll be able to see how we can scale up these ideas. So we created the Smart Incubator as a result of the experience that we had. Again, the geo-architecture was key there. And one of the things that I find particularly important is that when you start talking about global stuff, when you start talking about global solutions, for them to be global, you need global standards. You need open source. You need open hardware. And we said, okay, we are going to build a platform whereby people come with their ideas, And once they have these ideas, we give them some of the tools which are based on open standards, tools that are based on open hardware and open software. For open software, the solutions were based primarily on the geo architecture. So one of the things that we were looking at was, as I mentioned, how do people address the problems that they have so that the things that they have developed, the solutions they have developed would be applicable in their own environment. And in one of my trips, I listened to some of the types of problems that people can solve. And this is the kind of thing that we can apply also within the context of Brazil, where you look at the technologies, what they can do, the open architecture, and the relevant standards, and you try to see how you can put these things together. This is what we started looking at, and we realized that because it's an open architecture, we can plug in existing technologies into it so that the framework which is provided by the geo architecture becomes an enabler also for some of the technologies. And I think one example to actually use here is Internet of Things, or IoT. We looked at IoT and looked at some of the challenges. Some of the challenges have to do with the lack of interoperability of the identifiers which are associated to these devices. And also the fact that a lot of the devices also are based on proprietary technologies where there is no interoperability. So we looked at the challenges that we had to address. We looked at the features of the DOA. We looked at some of the other security implications. And we brought this together in one of the platforms that we announced at, I think at the last meeting we had, the geo architecture. We talked about the Advanced Information Management and Security Platform. There's this formula that we use, which is GeoIP plus IRP plus Y. Y is everything else that is necessary. Because one thing that we found interesting was the geo architecture itself has the fundamental, what you can call foundation on which you can build a lot of things. And that foundation is solid, it is open. So we brought in things like, the standards which have to do with IoT. We looked at some of the additional security requirements which have to do with, how do you enable secure communication between IoT devices, device-to-device communication. What I did was I sent a long presentation which has an overview of all of the things that I'm covering really rapidly, so that in case anybody wants to have more detailed information on how we have used the geo architecture and other related solutions, they'll be able to get that information. One thing I would also mention about this is putting all of this together, something like the AIMS platform, which is based on GeoIP, Identifier Resolution Protocol. These are the main protocols. GeoIP and IRP are the two main protocols that you find in the geo architecture. And then adding additional facilities on it. We put all of this together, and we are now in the process of putting in place what we call an open lab. And the purpose of this open lab is to create an environment where entrepreneurs, young entrepreneurs, startups who have ideas on solving problems. And that's the kind of thing that we would like also to discuss with our colleagues here in Brazil. You have an idea, you have some elements of the idea. How do we put this together? Knowing that, ingredients such as open standards, open hardware, open software are essential for you to be able to bring down the cost, for you to be able to, ensure interoperability, so that if you develop a good idea in Brazil, you apply it in Brazil, you can also become a global player. Nothing should stop you from taking that solution and, globalizing it. So this open lab, which is one of the things that we have put in place recently, is an element that is going to be quite useful for our smart incubator. We just the month of October, early October, we did open the incubator to all of our membership. And this opening of the incubator, it took place actually, I think, on the 12th of October. So it's very recent. We're talking about 10 days ago. We have sent correspondences now to all the membership of ITU, sector members of ITU-T and ITU-D, development and standardization. This was a joint effort between the two parts. So that while we work on the standards, the open standards and the proofs of concept, we work with the development bureau, which is going to, take those open standards, open software, hardware, concept solution, and scale it up. So one of the things that we have as the foundation here is how we can take these existing solutions we are discussing here and really empower, domains such as IoT. Have something which would really enable IoT deployment to get to a different level, because there would be interoperability, there would be the security, there would also be the necessary foundation which is provided by this open lab, the necessary foundation provided by the AIMS platform. So I think we are really at the verge of something which would again facilitate how technologies can be applied to solve a number of challenges that we are facing. And the COVID also pushed us a lot to innovate, because we did not have access to our physical infrastructure, and many companies don't. How do you do things, which require a virtual environment? And I think that as we continue these discussions, we'll be able to talk a little bit more about some of the practical areas where, we can look at, how we can deploy technologies, how we can address problems, and also how we can scale up and really become, even at a local level, but become global entrepreneurs. So for us now, it's about transforming ideas into solutions, making sure that we talk about all of those components, the relevant components and the domains. If at all you have a new idea, you look at how to cover the intellectual property, the global standardization necessary for it. And I think this is one area where we can really look at how the DO architecture would empower, some of the ideas that we have. And I'm looking forward to, drilling down into some of the things that we have just had an overview of, and how we can relate them to some of the things that Brazil might want to do. So, Mr. Chair, I think I will stop at this point, and if at all there are any questions, I'll be available to answer. Thanks.
So I wonder if I could just make one or two more comments just to build on what Alex just said. I'll try and make this very brief. I think he's exactly right that the way people will understand what this technology is about and how to use it is by example. So it's the various applications that are going to drive it home. I mean, in the early days of networking, people really didn't know what the networks would be good for. And we would go out with questionnaires and ask them what would they do, and they really didn't know. So we decided to make a spoof on the subject and say, well, okay, so suppose instead we would, give you 2 weeks on Mars. What would you do with 2 weeks on Mars? Well, suddenly they realized that this is not an easy question to deal with. Also, we get many questions from people who say, well, I don't understand why I need this. I have my files on my own computer. I use databases. I can access the clouds, services. I have maybe big RAID arrays locally, all kinds of local storage. Why do I need this? Or worse, if I want data, I just use the web. And so they don't really necessarily see in their own mind's eye all the potential for what you could do if you had a different foundational base on which to build, as Alex had just mentioned. I think it's probably driven home more than anything by the sudden appearance of all of this research data that's now starting to show up. So instead of a paper about research data. You can actually get to the research data itself. But, you know, when the web came around, people were wondering about, how do you find web pages to look at? And the search engines that got built, whether it was Google, Baidu, or whichever one around the globe, they were all getting their linkages by scraping other web pages, which was structured in a way that you could do that. There's no possibility of doing that easily for research data. And furthermore, the research data is so large that you can't think of sending it to you on request. First of all, they may not be willing to send it, and it may be terabytes of links. So it would overwhelm almost everything, local storage, the telecommunication lines, and maybe even the computing. So, I think we're going to need different strategies for dealing with that. This is how I actually started with mobile programs back in the 80s, thinking you had to send a program to these large sets of data to actually process it. That led to all kinds of security questions, and we ended up dropping that, which is how the digital object architecture came about, which is sort of like mobile programs without mobility, if you can fathom that. And then finally, we came up with a lot of early examples of where it suddenly made sense to people who didn't realize before that it was that powerful. So for example, if you have a lot of information in a cloud, that cloud provider may not be willing to move your data to some other cloud service if you don't want to deal with them anymore. But by using the digital object architecture to house it and using these services, as Alex mentioned, as proprietary back-end kinds of technologies to just keep your data, you can yourself move it from one place to another and keep all the metadata records to know exactly where it is, and you can deal with that easily. So I think it's a very important topic, but the most important thing that will probably only get through to people who are not developers is by actual working example. That's why I'm so happy to have worked with Alex over these years. And as he rightly pointed out, it actually all started in Rio in something like November or December of 2007, when it was actually the US government that suggested ITU should get interested in that. Now it's taken a lot of turns and twists since then, because industry woke up to this and decided that maybe it was something they should own and control. But in fact, something like this that's so important has to be an open architecture. It cannot be owned and controlled by one party. It's got to be a shared resource for the world. So back to you.
Yeah, thank you, Professor Khan. I think now we can enter on the debate phase. One point that I'd like to mention, completely agreeing with everything that you and Alex mentioned. We are talking about exponential technologies that are counterintuitive. I mean, we are talking about absolute truths, open standards, interoperability, global communication. But at this moment, very few people realize that in few years, we will have billions of IoT devices connected everywhere. And then I imagine that some decision makers will feel guilty to not adopt technology like DOA before. But talking about that, into the Brazilian perspective, we are having two exciting events despite the COVID-19. Next year, we hope to do our 5G bid, and probably will be one of the biggest in the world, because Brazil did its home lesson cleaning the spectrum. So it will be the biggest spectral offer in the globe, a huge opportunity for telco operators in 5G. And particularly in 5G, we have the IP and non-IP networks or devices. So, Professor Khan, can you explain how DOA can behave? You are one of the inventors of IP, and probably you propose a DOA in your vision because maybe the computing industry need to go beyond IP. And it's becoming very clear on 5G that we will have IP and no IP devices. So could you state your vision about these possible scenarios on 5G?
Well, I wouldn't so much focus on 5G per se. I mean, we have 4G and 3G and 2G. I assume 1G is probably not digital, but those are basically means of providing linkages so that you can move, let me say, identifiable pieces of information around. I mean, even in the internet itself, everything that moves in the internet is identifiable. But just right then, for while it's in the network knows what it is, but once it's delivered, it's gone. You can't say today, unless somebody is keeping track of all of that stuff in some private separate system, I would like the packet that Alex sent to somebody at ITU, or maybe something to Brazil in 2008. Because nobody keeping that information. It's not persistent. I mean, it literally is right there and then goes away. So I think that the issue of managing information really needs to be separated from the kind of facilities that's transporting the information from place to place, whether it's going over wires or fibers or cables, or whether it's going over the air through satellites. I mean, those are just transport means of getting bits reliably from one place to another. Now, that's a challenge if you want to do it without having to know how to route through the telecommunications universe. That's what the internet ended up doing. And I think it's, done pretty well so far. That's not to say somebody won't reinvent a better way of doing it, but, the internet's been around for 50 years, roughly, and it's scaled by a factor of probably, I said 10 million. It may be closer to 100 million if you look at computing speeds, communication speeds in the backbone, look at the amount of memory for the same amount of money you can buy, and I see no end in sight. So that's because the principles on which the internet was based were scalable. I mean, they were open and they allowed this kind of growth. So the technology we had back in the early days doesn't exist anymore. I mean, the only computers were in big air-conditioned rooms. Couldn't carry them with you. I mean, we are so far beyond that now. It was probably not imaginable for almost everybody back 50 years ago. Who knows what it's going to be 50 years from now? But I think we need to separate the two. And so what the digital object architecture is about is building on top of that kind of high-speed, navigatable, communications infrastructure to allow us to manage information. And Alex hit all the high points. I mean, he's really very good at that. You got to know what you're looking for, how to find it. With the internet, you start out for the most part of wanting to get information from here to there. You want to talk to a specific person. You're in charge of everything. You're navigating it with your fingers on the keyboard. In the informational space, maybe none of that happens. Maybe it's all up to the machines to figure out what other information they need to take the next step, maybe even to figure out how to route something and so forth. So I want to try and distinguish the question you're asking from what I think the reality is. 5G will just simply enable lots more interesting stuff to happen. But what the DOA is dealing with is basically interoperability of systems, no matter at what speed and no matter whether it's 5G or 6G or 10 to the nth G, or persistence, so that the information, once you've created it and suitably made it known to other parties, it can be found not only now, but next year. And for some kinds of information, you may want it around in perpetuity, which is why I asked the Jose from the government the other day, whether the government was considering, managing its information, because much of what they do, they may want around in perpetuity, literally forever. And then finally, security is really interesting and important. But I believe if you really care about it, you've got to deal with it at the object level itself. It's not enough to know that particular wire somewhere in the world was encrypted, because ultimately when that information shows up in a machine and it's processable, it's going to probably be in the clear, and you may only want that to be either in your machine, which you control, or in a service that you know and have certified that it is securable enough, and they treat the material securely enough for your purposes. So let me stop there.
Alex, do you want to make some comments about that?
Generally, you know, I think when we look at networks or the transport mechanism, the way I see it, all of these things exist because of the content. And you know, as Bob was saying, there would be different mechanisms to move information from point A to point B, but this become more and more transparent to people. You know, in a short while, the network, people might not even know that it exists. The only thing that people are going to look at is the information. And I think that, you know, it's one of those areas where, depending on what you want to do with the information and how soon you want it, then you might be interested in some of the capabilities. I was reading something today where somebody was talking about the impact of 5G in terms of, you know, the latency. Do you need something to arrive within 10 milliseconds? Is it everybody who might want, you know? So I think it's an interesting point you raise. But I think that eventually what is happening is that the network, its capacity in terms of speed, its capacity in terms of latency would basically depend on what it is that you want to do with the information. But the information becomes the primary thing. And as I mentioned, it is going to be something that would make the changes. Right now, it appears as if we have the network, and then the network determines what we want to do. But I believe that eventually what we want to do would determine what the network is. That's what I have as comment for this.
Yeah. What happened, that was a good point. A few weeks ago in Brazil, the two national standards for digital cities have been published by our national standardization board, Brazilian Board for Standards, an ISO. And we have city elections in December now. So we see our mayors quite eager. They are proposing in the city plans, deploying digital cities, you know. And again, open standards like DOA to interoperate millions of city assets, it will be quite relevant. And maybe some concepts, despite we talk a lot, some people do not realize that is the relevance of the persistence information on digital objects, because real objects are also persistent. And very few people still do not understand this requisite. Regarding this point of persistency that Professor Khan mentioned, Alex, could you give us one or two examples about how DOA can do the full difference when we consider this persistency requirement or characteristic of DOA?
Yeah, for an organization like ITU, where, you know, we get a lot of information coming from the membership, you know, we have to make sure that we have a very clear distinction between something and its properties. You know, the idea of something and its properties, because it's a simple thing. You know, right now I'm in Geneva, but when I go to Brazil, I'm not going to be my ID is going to be the same. So for you to be able to manage information properly, especially as I mentioned, for a standards organization like ITO, where you have a lot of things coming in and then they are mixed and then you develop something else, but you still want to be able to make reference to the origin of all of this. You need to make sure that the way you deal with things, you associate them. In fact, the example that I gave to you, it was a little bit like people thought, is this really possible? When they realized that we could create interoperability of, heterogeneous information systems. We could create, the relationship between things because the ID remained the same, it was persistent, and the status is the one that would change. So we have seen significant amount of benefits in terms of the things that we can do, in terms of the types of applications we can provide, just by making sure we make this distinction between the ID of something which should be persistent and the state information about that thing. So when you look at this, you realize that the same thing applies in almost every domain, whether it's human beings or it is IoT devices or it's information. You really want to make sure that you can really manage the object properly because you have been able to make that distinction. And that distinction enables you also to create relationships between things. And even though the two things might change, the relationship remains the same, as long as the change is not, breaking a relationship. So one is muting, is being modified in one side, the other one is being modified, but the fact that they are related still remains. So it's a very powerful concept, actually. It's the one thing that when I realized the possibility of doing this, my first introduction to the DOA, and I could really see the power of this. And this is what we are applying, and we have applied in a number of areas. Thanks.
We are quite excited down here at my center at USP because we got one contract to do a large-scale pilot in Brazil on IoT, on urban security. And we just signed an agreement with our state police. And we want to do crime notifications using AI and IoT devices. And that's a very clear example when you declare to an authority that there is a potential crime here or there, the persistency is something really important for the police authorities, because it's something formal that needs to be declared to the state, So in these situations where you need to notify a crime or you need to keep this information viable for a long period of time, the persistency requirement is really clear. Problem in USA, you have the 911 service, right? You call police through 911. What we are doing successfully here as a pilot is just a proof of concept. We are using small IoT devices. For example, someone show up with a pistol here. It's not normal, a pistol being on a university lab. So that is immediately notified to the police. Here, someone showed a pistol on a research facility at down USP. So this kind of information, we start to test, notifying to our authorities. And then one officer asked, how I can make sure that that information is real, has some reputation, and is persistent. I said, well, we are considering to use a technology named DOA that has these persistence requirements, and it's a global standard. So that could be used not only by the Brazilian police, by police everywhere in the world. So that's a very clear example how persistence is something important on the domain of IoT. Professor Khan always mentioned the thing of scalability. Some applications on IoT is showing up in Brazil where easily we will need something like 10 million devices for a single domain application. Professor Khan, when you designed DOA, could you tell us what was your key ideas to guarantee that DOA is scalable?
Well, you might as well ask that same question about the internet, because it's the same principles, namely open interfaces, no nodal points. I mean, there's some architectural principles that you get to look at. I mean, the fact of the matter is, you could look at, let's say, the identifier resolution system that Alex mentioned. You know, I don't know how many identifiers it's dealing with right now, but it's got to be, I mean, billions, maybe trillions. I just don't know how many are out there because there's no central point of control. So individual organizations that want to identify their information can do it. And there's a set of, again, a distributed set of organizations that help to maintain a scaffolding for this so that, you know, you can know that these pieces of information can be resolved properly, these identifiers. But it seems to me it's just a matter of good architecture. You know, if you try and ask, you know, a major architect, I.M. Pei, or somebody who designs beautiful buildings, or innovative building, Frank Lloyd Wright or whatever, what is the key idea? I mean, it's sort of, to them, it's probably just intrinsic. They just, you know, see it and know it. Ask Alex what it was when he first heard about the digital object architecture that got him interested. I mean, it's not like he ran through a checklist. Does it meet point A or point B? I mean, it's sort of, it's a conceptual whole. You look for what the flaws are. You know, does it depend on, you know, one person in Rio de Janeiro doing something, and what happens if they get sick, the whole thing fails? That's a really lousy architecture. But when it's so fully decentralized and distributed, you know, then it can work. I mean, an awful lot of people will look at a system and say, well, we need to come up with a new system for decentralized identifiers, because the one that is being used in the DOA has a small set of organizations giving out prefixes, or it's administered in some central way, but almost everything that's going to work is administered in some way, or may have some critical flaws ultimately. So I guess on the scalability thing, I think we've already seen that scalability is possible in the identifier system because it's scaled dramatically. We know there's scalability because the repositories are all run by the parties who have the information. So if you had, you know, 1 million organizations, you'd probably have 1 million or more repositories. And the same is true with metadata registries. They can be as distributed as you like, and they're all linkable. It was one of the things we talked about a lot in that ITU recommendation X1255. So let me just make 2 other comments, and then I'll stop. One is interoperability. I think is really a very key feature here. That's what the internet was all. That's what TCP/IP enabled to first order, and interoperability is going to be important. I mean, just in a COVID situation, if you're traveling from one country to another, you would like your health records to be accessible no matter where you are. You don't want to show up in Brazil and say, well, we have standard blah, blah, blah. And, you know, your system doesn't comport to that. So you need to convert it, and you need the health support right then, the medical care right then. So you need interoperable systems. I think in the Internet of Things, same thing. Every group that is dealing with it understands interoperability is important, but they don't think of it globally. So if you're dealing with automobiles, they'll tell you what they're working on for automobile to automobile interoperability from different manufacturers. Same thing with airplane to airplane interoperability. But they're not thinking about how do the airplanes communicate with the cars. An airplane may want to land on a highway if it's running into a problem. They don't want to crash into the cars. And virtually everything may need to interact with every other thing, no matter how big or small it is. I think one of the things we're going to learn is that there is a whole research topic that has to do with how one interacts with things. Right now, people think of a thing that does one thing, like a thermometer. But, you know, an airplane or an autonomous vehicle it's a thing, but it's got many different functions and many different ways to interact with it. And I think that's going to be a very interesting research area in its own. And then the final thing is how you get things out and deployed, which is the main topic you started with. And when we were doing both the ARPANET, I mean, what we did there was we actually deployed a working network right out of the government. And so what people only had to deal with is their own aspects of it. Then we started to work on interoperability protocols, but that was just for transporting the bits. When the internet came around, we actually had reference implementations of TCP/IP. So people wanted to get started, they could. And it was all driven by the research community, because those were the people who had enough vision to see what this might lead to in the future. There were no commercial applications, but once you got to the point where there were enough working examples or even a community, then commercial interest started to peak. And once you had commercial systems out there, then the rest of industry got really interested. You had commercial firms not only building the applications, but also the underlying technology. So they no longer had to deal with reference implementations. They could go out and buy it from companies that would then supply it, because they just wanted the capability for some application purposes. So that's what we need to do. So we need to get enough examples out there where people can see it. So commercial firms will start to be interested in making the technology and its application available to people so you can buy it through the commercial marketplace mechanisms.
Thank you. Just to give, talking by ourselves, we have our meeting on November last year in Beijing, and where we agreed to deploy a DOA test bed in Brazil, down here at University of São Paulo. And another point that I want to make clear to the audience, we had deploying a DOA on very small devices, like this small computer that is the Labrador, but it's a computer. We have 2 gig RAM, 4 processors, but more recently, we deployed DOA in these very tiny devices. That is an IoT gateway with a 32-bit processor. And that's something very important to mention to audience. DOA is super light. You need very little computing resources to deploy a DOA piece of software on an IoT device. And here at the university, we are trying to create this community down in Brazil. It's open to everyone. But my researchers, my students are quite excited about running DOA in these small devices. We also have a very nice surprise with the team of Alex Nitoko and the Dona Foundation. We spent 15 seconds installing the Java software on this device. So in less than 15 seconds, since you have Java installed on a computer, on an IoT device, it doesn't need more than few seconds to have a DOA infrastructure running these small devices. So that's very important. And we have a question from the audience about a roadmap, how to deploy DOA. So what we can say from USP side, we had this BNDES pilot on digital cities running with the police department and with the public transportation service. And we want to make it open to the community. So our experience deploying DOA, configuring servers, connecting them to Dona Foundation, we are learning from scratch. And we want to do some reports to help the local community understanding the process. But I should say that is not complicated. Some fundamental concepts like persistency, interoperability,
security,
they are key, because suddenly users will realize that on IoT is exponential. So suddenly you guys will have something like 1 million devices, and you'll see how it is important taking these decisions prior to avoid legacies. So maybe at this moment, we can open questions for the audience. We have few questions here.
Marcelo, before you do that, can I just make ask you a question? You talk about, deploying DOA. That's an architecture. An architecture is really a specification for something. So what you're really talking about is deploying an implementation of the architecture.
Yes.
Because that's what you use. Java also is just a language that you use to write things. And so I know I didn't want to belabor it, but one of the things that we do at my organization, CNRI, is we build reference implementations. So we built a reference implementation that involves almost every aspect of the architecture, which we call Cordra. I know we talked about it in Beijing at the time. And that is a Java implementation that we made available, and including the interfaces to it, which we made available to the Dona Foundation. That's just what kind of things we do. They're open to use by others and open source type licenses. So to what extent were you using either Cordra or something like that, or did you write your own for any of that? You wouldn't have done it and implemented in 15 seconds, I believe. So
yeah, what we did, I'm sorry to be more informal. You are absolutely correct, Professor Khan. It's just because people are asking in the audience here how to make DOA concrete. So basically what we did, we had a meeting with some engineers from Dona Foundation, Vinesh, and we pull up a single board computer from my backpack, and then we connect to the internet. We download Cordra, I think 2.0.
yeah.
Vikesh asked, well, what is your computational infrastructure, particularly on our open source, open hardware? We decide to install a full Debian kernel, the Debian 11 now. That is one of the most complete and most open Linux distributions. They claim that they are the most open one. And this Linux distribution, Debian 11, it came complete with the up-to-date Java libraries. So since you have this infrastructure on an IoT device, and that is a Brazilian thing, that is Caninos Loucos, the crazy dogs, the Labrador, the dog computer.
Mm-hmm.
In 15 seconds, we download everything, we opened it, and we run it. And it was a kind of magic, on this very small device.
So you're running Cordra on that little device?
Amazingly. Okay. Super fast, super quick. And at the same time, what we're doing, we are running AI for the police. So the police give us 100,000 pictures of people carrying pistols. So we trained a small neural network here. We attach to a camera, so the camera will see a pistol. Immediately, we notify the police with DOA and persistence. That is what we're building in our reference model to deploy safe digital cities in Brazil. And something that is important to mention to the audience, I see, Professor, that I'm being more not rigorous on a reference model, but it's just to give a glimpse to the audience how easy and how is not complicated. Because again, to clarify the audience, there are wonderful reference implementations of DOA, like Cordra. And particular, Cordra is on the version 2.0, Cordra 2.0. That is the DOA architecture reference implementation. And you just download. It's free, it's open source. And that is a way to people familiarize with DOA.
Well, I would also add to that, we hope commercial organizations will build on that, because that's the way That's the way it becomes pervasive in society. But you kept mentioning AI, and I think that's one of the areas that people are now making more research inroads in than ever before. This is a topic I'm very well aware of. We supported a lot of the early AI research. It's gone through waves, up and down as people got more motivated and less motivated. But I think one of the challenges going forward is that we need to get the AI community to understand that there are advantages, and I won't try and elaborate them now, to putting all the information that they manage with AI type programs and machine learning on a digital object basis, so that they can uniquely identify the information, they can uniquely pass it, that programs can talk to each other that are AI programs. They're not there yet, but I think this is going to happen. And the more that the research community can understand that, the better we will all be.
Maybe later, since this large-scale pilot with the police is open in Brazil, the first requirement that our state police asked was, it need to be fully open. As a public authority, our state police, like let's say New York police or wherever, we need to rely everything on open standards. So they are not technically familiarized with ITU, DOA, everything. So we spent some weeks explaining them. But the workflow is very simple. We have an AI algorithm generating semantics described by XML kind of stuff. And that goes to a DOA pipeline. So we sign the persistence and then we do the notification. Very simple. But maybe later I can show you that to you and Alex, and that could be a concrete case in Brazil. We're using DOA to do crime notification here. I think we somehow answered the question of Cecilia. We need to have a roadmap to start using DOA. How to start? I will recommend, Cecilia, downloading Cordra and accessing the Dona Foundation website. If you have some difficulties, you can send us some message. But I think, particularly with our National Developing Bank large-scale IoT pilot, we will publish some implementation reports, and that eventually can make it easier to you. Gabriel is asking a question. Yes, please, Gabriel. I'm sorry.
I would like to make a question for Alex and Bob. I believe that the question is very good, but maybe, and my question is, the Brazilian IoT Forum could work together with DONA and ITU, and have here some training course where we would teach the basics, because I think that of course the people can go to DONA and do, but I think that if we have here some material prepared and we could try to prepare a course. I know that Alex showed to me sometime that ITU made some of this material. If we could work with this and offer to, in Brazil, in Portuguese or maybe in English, but translated, that could be better for we to really give this type of information for people. Because I believe that even maybe that some people that they have courses could ask to use this material. Anyway, is it clear my question? Could we start to make it something that would have, like she said, a roadmap? First train some people, and then we have to have clear the question of how to make a number, an identification that is valid in all over the world.
Gabriel, just to give an example, here at the School of Engineering at USP, we have our course on embedded computing. So we ask students to use drones to recognize objects on the environment. and they do, since they recognize a chair or a table, they do a digital object notification. No, we have already some, not a complete course, but we have some classes, hands-on classes, where we combine computer vision with DOA to object notification. So the whole idea is one drone walk around, recognize a chair, and notify, well, there is a chair here, and that's a digital object. And then the second drone come back. We try to explain the concept of the persistence, how important having the persistence, because doesn't make sense all drones recognizing objects all the time. You know? We can have a centralized data server where with persistence, and that is DOA, where we can keep all recognized objects on a central information facility. But I think you're right. We should do some training materials to educate the Brazilian community. And the Internet Forum is the main, is the center for that, in my opinion.
Let me just weigh in here a second to say that this is something that we've talked a lot about in the Donor Foundation itself. And the executive director there, who's a fellow named Christophe Blanqui, is actually, he hired a technical writer for the purpose of informing people. There are really two aspects of this. One is sort of the background and the basics. You know, what are we talking, what is the DOA, what are the components of the DOA and the like. And so he's been trying to generate material at that level, and I haven't seen any of it yet, but hopefully it's not going to be overly technical, but will be accessible by people who are scientific in background, but without a lot of actual detail, because even the woman who's writing that is not that technical, though she's good at technical writing. And the second one is what you're talking about. How do you get started? I get that question all the time. And that's something I don't know that he is working on, but I don't think that it's something that would be a bad idea to get working on it if they have time to do it. We might be able to help. And you know, part of getting started will be pointers to where you can go to get the components of technology. I don't necessarily want to, you know, overemphasize what we're doing, although we've been central to a lot of it. But, you know, some of it you can get from the Donor Foundation, not because they have a big software staff, it's because either we or somebody else develops it and makes it available to them to then either own or further distribute. But it's going to be from different parties. I mean, you're talking in your own work using Debian. Well, that's something you don't own or control, but it's available. And so you can use it. And so we need to point out all the parties that need to be involved. So we probably need to be involved. The Donor Foundation would need to be involved. It'd be great if ITU could be involved. It'd be great if some of your universities could be involved, and maybe others around the world who can equally well contribute.
Let me add something here. Whenever you look at, you know, trends, technological trends, you know, sometimes they are quite fascinating and you get interested in them. I always like to look at things from the point of view of what is it that you are trying to do? What is the problem that you are trying to solve? You know, I spent some time in the development bureau of ITU, and I'll go to some countries and they'll say, oh yeah, we hear that you have come to give us a solution to our, you know, to fix our government. I say, okay, first I need to understand what is the problem, because the technology comes as a way to solve a problem. It's, you know, you're applying some kind of science to meet certain objectives. I would turn the question around to the Brazilian community and say, what are the problems that you want to solve? If you don't have a problem to solve, unless you are just interested in knowing about the technology, you know, it would not be that relevant. You will not really be able to see the features and be able to relate them to how you can apply. So you can do what some consider top down and bottom up at the same time. The technology is there, everything is there. Maybe what we can do, as Bob mentioned also, we look at this whole idea of concept solution, something that we hope would give you an example of what it is capable of doing. And then maybe that is going to relate to the problem that you are trying to solve. And then you begin to see what questions do you ask about the geo architecture, and what are the things you need to go deeper into. So that's one of the things we are planning to do in the incubator. The incubator is where we put in some of our concepts. We have the geo architecture running on it. We give you access to the standards, and you come with your problem. You come with the challenges that you want to solve, and then we try to see. So you would be learning how to use the open architecture at the same time, the open architecture and the related technologies, and at the same time, you really see the purpose of using it. This is something which, as I mentioned, you could learn something, but it's not very easy for me to explain what the capabilities of geo-architecture in a way that somebody would feel like they really need it, unless I know something about that person to be able to give a relevant example. So that's why my presentation is 60 slides, because I'm trying to cover a wide range of different topics to hopefully get, those who see the PowerPoint, for them to see something which, means something to them, and then they begin to go deeper. So that's that's the comment I have on this question. That's my response to your question.
Alex, I actually have a question for you. If somebody were to ask you why they should get a college education, what would you tell them?
If somebody asked me why I should get a college education.
Not you, but they should get a college education.
Okay.
You have too much education already.
What I'm going to tell them is that we live in a knowledge society, and the more information you know about how to survive, the better your chances are to survive. And the college education will give you the tools, the knowledge that would enable you to, go ahead. But then if the person says, well, I don't really want to go ahead, I'm fine where I am, I don't have it.
What problem is college solving for me?
Well, all of the stuff that you're talking about now, if you didn't go to college, how would you have ever been able to start the internet? You probably learned networking somewhere, computer science, and all of that. So, I could see definitely what college did for you.
Right. Okay.
It seems that Marcelo get down. We have really only 5 minutes more. After this, I would ask you to stay, see the next presentation. I think that it will be good for you. It's a presentation about the Brazilian infrastructure in the internet. I think that it could be worthwhile for you to see that we keep doing things in the best way.
I have another meeting which is starting.
Carol, Marcelo is asking if you could help him to enter in the again. He's back.
Oh,
but, Alex, please, Alex was starting to talk. Please.
I am back. I have a connection problem.
Marcelo, we have just 5 minutes now. See if you want to make some final points and ask them if they want to make it.
Yes, I think the clear next step is starting some demonstration projects, or as Alex mentioned it, an open lab down here. The national planning IoT is moving according to the reports that we have from the Brazilian government in this week. We will considerably enhance our national communication infrastructure next year with 5G. So as Professor Khan mentioned it, is just a newer technology to connect more things, but such things need to be interoperable, need to be persistent. And exactly like Alex mentioned it, it's not only about technology. We need to understand our real problems in cities, in health, in safety, security, more recently in COVID, and understanding the potential of the DOE architecture, tackle concrete and real problems. I don't know if Professor Khan and Professor Alex want to do the final comments, but I think we had an excellent conversation here. And just for the comfort of everyone, maybe 1 minute to Professor Khan and 1 minute to Professor Alex, and then we conclude our debate that I believe was excellent. Professor Khan, do you want to do final remarks?
Well, I made the opening one and went first. Maybe Alex should go first now because he has something else he needs to go to in a moment. So let me refer to Alex and then I'll follow him. Okay.
First of all, Marcelo, let me thank you and Gabriel and all the those involved in the 5th Brazilian IoT Congress for inviting me. And I hope that this is part of the journey that we would continue to, working together and seeing how we can use the geo architecture in addressing certain very concrete challenges that you want to put in place or address here in Brazil. You can count on our support, and we look forward to continued collaboration with your UPC. Is that the proper acronym?
USP, University of São Paulo.
Yeah, sorry, USP, yeah. With USP, with Brazilian IoT, and we continue this discussion that we started some years back. So again, thanks for the invitation, and we stay in touch.
Thank you, Alex.
Okay.
And just to finalize, Professor Khan, thank you also for your inspiring comments. Your long-term contributions to the field will last for much more years. Thank you for your vision.
That's been my pleasure too, because it's not only been a contribution, something that gives me a lot of pleasure, but it's it's been fun. I mean, it's been a very interesting and interesting. So what I want to say is we actually have different kinds of communities that we end up appealing to. There's the community of people that become the end users. There are the community of people that become the infrastructure providers. There are the community of people that sort of are innovating and inventing things. So, we've been talking a lot about looking at the potential uses. That's true when something is mature. I think Alex is asserting that maybe this is more mature than other people might think it is. I think it's pretty well along. I think that's not a bad assumption, but people have to then understand it. You can't use it if the technology doesn't exist. It's not enough to have an idea. Jules Verne had an idea for an underwater submersible in the mid 1800s, but it was a long time after before that technology could be realized. So you have to actually implement it before it can be usable, and you can't use it if it doesn't exist. And the only way it can exist is if you can imagine it. So when we started a lot of these activities, people couldn't imagine applications for it. Unless most people couldn't. And if you had to have these things funded based on a real immediate need, we never would have had the internet in the first place. It was based on an assumption this would be useful. If I could have cited the pandemic 50 years before it happened as why we were doing it, maybe it would have gotten a motivation, but it was based on the idea this was just a good thing to do. And I think being able to manage information in a way that's interoperable with other systems, it's a way that's persistent, a way that's secure, long term is just a good thing to be able to do. It's good practice. It's like using logic. It's like, being smart about what you do. It's like having an educated approach to things. If I could have thought of a better way of doing it, I would have put forth. But here it is, many, many years later, and just like the internet, it's still around. Why is it still around? Because it served a purpose. It was functional. It scaled, and it had all the properties that people needed, at least for them. Will it be around forever? Undoubtedly not. Somebody will come up with a better idea. Maybe there'll be quantum digital objects, and we'll have to deal with them in parallel ways we never even thought about. But I think we need to take into account both of those things. The people who are innovating and creating the systems and building the reference implementations are the ones that are exercising imagination and sort of faith in the future and creating possibilities for people to use. But when you want it to expand widely, people have to understand what it's going to do for them. And that's a different type of argumentation. That's a different type of community to deal with.
Okay, thank you. It was a pleasant, and times fly, We talked for almost 1.5 hours, and it seems that we spoke for 10 minutes. Unfortunately, our time finished. So I'd like to thank you again, Professor Khan and Alex. And I will conclude now. Thank you, Gabriel, for the invitation, and thank you for the audience. Have a nice day, all. Thank you.
Thank you.
I would like if Alex and Bob and Sam could stay here. I want to really say a very, very, very thank you for being here and helping us in this process. I believe that you understand now how we try to work. Is one step by step, but we never. I think that now the next step should be this one of that we were talking how to teach the basics. I will try to enter in contact with you and Sam to see how we could do something that makes sense and it's good. And of course, Marcelo is our key element here. Bobby, Alex, and Sam, at least, I will call in just a minute Milton to talk about our infrastructure in Brazil. And Brazil just got first place in best operating internet in the world. I think that it's worthwhile for you to see that we do much more things than sometimes we believe.
Gabriel, before we do that, I know Alex has said he needs to get into another conference, so he may not be able to. That's his call.
Yeah.
But how long is this presentation? Because I had other things scheduled as well.
It is 30 minutes. Milton is here. Please, he will speak in Portuguese. Go to the interpretation in the part below and click that you want it in English. We have, and then you, Milton, I believe that you can present yourself.
Gabriel, I will stay on as long as I can. Alex will probably do the same. He knows what his timing is. If I have to drop off, I think Sam will be on and he can fill me in on what happens, but I'll stay on as long as I can.
I need to drop off. I have to finish something before a major meeting this afternoon. We have a crisis management.
Anyway, Alex, thank you very much.
Okay. Thanks.
Okay, I will call Milton now. Milton, you can. But he is a long-time member of Nick BR, that is our operator here. Milton, please put this.
Okay, thank you. I will switch to Portuguese. So, é prazer estar aqui, a convite do Gabriel, do João. E é prazer rever o professor Bob Kahn. Ele esteve nos visitando lá no Data Center do NIC. Foi prazer enorme recebê-lo. O interesse enorme que ele teve em em fazer as perguntas técnicas sobre a nossa infraestrutura lá do data center do Nick João Dias. Eu vou colocar, eu vou compartilhar minha tela aqui para poder fazer a minha apresentação. Conseguem ver?
Sim.
Sim,
Ok.
está aparecendo.
Tá legal. Então, eu vou começar aqui, né? Quer dizer que comentando que esse ano aqui a gente completa, a gente está há 25 anos aí da internet comercial aqui no Brasil. Tá? A internet acadêmica aí aqui no Brasil começa em 88, antes da internet. A internet aqui no Brasil só começa em 91, né? E vamos dizer assim, muitas coisas passaram desde então, né? Agora, eu vou focar mais na internet comercial, né? Quer dizer, que dado o interesse de crescimento geral que teve, né? Então, basicamente, né? Quer dizer, que um dos players importantes aí, uns atores importantes aí da parte do ecossistema brasileiro aqui, foi os sistemas autônomos, né? As redes brasileiras. A gente vê aqui a curva de crescimento das redes brasileiras, que hoje, em 2020, atinge 8.468 sistemas autônomos atuando aqui no Brasil. Quer dizer, no início da nossa internet, em 95, eram poucas dezenas de sistemas autônomos, e agora a gente tem esse número fantástico, aí, superior a 8.000 sistemas autônomos. Sistemas autônomos, a gente tem que diferenciar um pouquinho em relação às empresas de telecomunicações, porque também incorpora as redes acadêmicas, incorpora as redes de governos, incorpora as redes de conteúdo, incorpora as redes de empresas de grande porte, bancos. Então, o que distingue uma rede de uma empresa de telecom, ou se não elas se juntam nesse conceito de sistema autônomo, é que ele precisa ter uma rede física e precisa ter roteamento, quer dizer, precisa ter condições para poder ter vários caminhos para poder chegar até o seu destino final. Aqui a gente vê um espalhamento aí de como está o sistema autônomo aqui no Brasil. E a gente vê aqui...
Desculpa interromper. Pode colocar em modo apresentação os slides, que para a gente estar parado no segundo slide.
Está parado no segundo?
É.
Mas está em modo apresentação, não sei como é que...
Ah, para nós travou. Se você...
Travou?
Travou, o slide.
Eu vou então interromper e vou
Ok.
voltar.
Agora, ok.
Vamos ver.
Tá passando?
Eu estou tentando, vamos ver. Ok?
Agora tá ok. Perfeito. Obrigada e desculpa interromper.
Ok. Está vendo o gráfico de crescimento?
Sim.
Agora a distribuição, o mapa com a distribuição de sistemas autônomos.
Sim. Perfeito.
Aqui temos a distribuição geográfica, né, por região e por estado, né? Vocês podem ver que o Sudeste tem uma concentração bastante grande. E, vamos dizer assim, importante dizer que sistemas autônomos aqui no Brasil, né, que atuam como provedor de acesso, né, eles se concentram bastante aí na região Sudeste. 39% atuam na região Sudeste, sendo que na região Norte, que tem a menor quantidade de provedores de acesso à internet, né, representa 6%. E muitas dessas empresas aí são empresas pequenas, que têm poucas pessoas, de 1 até 49 empregados, representam 88% desse total de provedores de acesso à internet aqui no Brasil, segundo a pesquisa do CETIC e do NICBR. Importante ver como é que esses provedores atuam aqui no Brasil, né? Importante dizer que, para poder atender o usuário residencial, algo como 60% a 70% do conteúdo necessário para poder atender os usuários residenciais, eles se encontram nos pontos de troca de tráfego. Tá? E quando ele vai atender o usuário comercial, algo como de 50% a 70%, ele encontra no ponto de troca de tráfego de São Paulo. Ok? Então, eles começam aí atuando dessa maneira, conectando aos pontos de troca de tráfego, e quando eles crescem, né, eles solicitam caches de conteúdo para as principais empresas, né, de conteúdo, tipo Google, Facebook, Netflix e outros aí, para poder ter esses servidores de conteúdo dentro das suas redes. Ok? Esse número de empresas aí, algumas delas também não são sistemas autônomos. Então, que a gente tem muito mais do que empresas atuando nesse mercado do que simplesmente as 8.000 redes que eu tinha citado aí. Tá? Então, 7.000 são empresas autorizadas pela Anatel, mais de 7.000, e esse número tem crescido, né? E assim, porque a Anatel reduziu bastante os custos para poder obter autorização e atuar nesse mercado. E também, né, é importante frisar que essas empresas estão aumentando em número porque as tecnologias têm reduzido seus custos, né? E com isso tem sido fácil as empresas serem criadas e começarem a atuar em locais que não existe infraestrutura. E as associações, tipo a Brint, a Branet, Internet Sul, Rede Sul, a Bramult, têm ajudado nesse processo. Um outro aspecto aí são os pontos de troca de tráfego, né? Importante aqui no Brasil, né? Porque deu condições para que esses provedores de acessos crescessem. Então, aqui tem a distribuição geográfica dos 33 pontos de troca de tráfegos que a gente tem, né? Sob administração do NIC.br, né? Então, a gente tem pontos de troca de tráfego espalhados por todo o Brasil, inclusive em Manaus, tá? Que dista algo como 3.000 quilômetros aqui de São Paulo. Eles não são interligados, eles não são interconectados. Então, eles são infraestruturas isoladas, no qual os provedores chegam nessas localidades. Os sistemas autônomos chegam nessas localidades. Então, aqui a gente tem aqui, né, uma visão aqui do que tem acontecido aí nos últimos anos, né? Crescimento de tráfego ascendente, né? Crescendo aí ano após ano. A quantidade de sistemas autônomos aí nos 3 últimos anos superaram mais de 1.000 sistemas autônomos por ano. Então, o mercado brasileiro aí tem crescido a olhos vistos aí. E em termos de tráfego, né, a gente conseguiu no agregado total aí, no melhor dos picos, 3,5 terabits por segundo, tá? No agregado total. Importante frisar também o papel das empresas de transporte, que possibilitam que esses provedores chegam até os pontos de troca de tráfego. Então eles oferecem esse serviço de transporte principalmente para os pontos de troca de tráfego que têm bastante participantes e devido a uma grande oferta que tem nessas localidades. Os preços são bastante interessantes, bastante baratos para esses provedores poderem contratar e participar dessas infraestruturas que tem grande quantidade de participantes, que no caso são São Paulo, Rio de Janeiro e Fortaleza. A atuação desses provedores aí é interessante, né? E também das empresas de transporte, porque eles além de oferecer transporte, também acabam oferecendo trânsito IP, né? E também um serviço chamado trânsito de conteúdo, né? Trânsito restrito aos conteúdos, que são aqueles caches que eles têm dentro das suas redes, ok? E às vezes, né, quer dizer, que esse serviço chega a ser mais interessante para o provedor de acesso e aí fazem com que eles se desconectem do ponto de troca de tráfego local aí, de onde que eles estão participando. As CDNs, né, as empresas de conteúdo, são importantes atualmente, né, por causa que o grande volume de tráfego está centrado nesses servidores de conteúdos. Tá? Então, se vocês olharem a coluna aí, que está São Paulo, mais à direita, né, você vê que todos esses provedores de conteúdo estão presentes na estrutura de São Paulo. Aí, em segundo lugar, Rio de Janeiro, né? Depois Fortaleza, Curitiba, né? Mas as outras localidades, dificilmente essas empresas colocam suas infraestruturas. Então, a gente lançou um projeto chamado OpenCDN, né? Começando na cidade de Salvador, para justamente poder levar o conteúdo para essas cidades. É um meio termo entre você ter esses caches por estrutura própria deles e aqueles caches que são colocados dentro das sedes dos provedores de acesso. Aqui falando aqui, né, pessoal, o ponto de troca de tráfego de São Paulo, ele é considerado hoje o número 1 do mundo. Em número de participantes, tem mais de 2 mil redes conectadas nesse ponto de troca de tráfego. Superou a marca de 10 terabits por segundo de pico. É o primeiro ponto de troca de tráfego no mundo a superar essa marca. Então, por esses dois quesitos aí, ele é considerado o ponto de troca de tráfego número 1 do mundo. Aqui está a distribuição geográfica dos participantes do ponto de troca de tráfego de São Paulo no início desse ano. Mas hoje já temos mais de 2 mil sistemas autônomos. Aqui temos Rio de Janeiro, né, com 1,5 terabits por segundo de pico, e a distribuição geográfica dos seus participantes. Então, vocês podem ver que nem todo o Brasil se conecta no Rio de Janeiro. Então, essa parte cinza é onde que não tem nenhum participante, né, e nesses estados não tem nenhum participante que vai até o Rio de Janeiro, coisa que já não acontece em São Paulo. Aqui é a estrutura de Fortaleza, que está alcançando 600 gigabits por segundo, né, e crescendo. A gente acredita que vai superar 1 terabit por segundo logo, logo. E é importante frisar que tem vários participantes, principalmente da região Nordeste, né, quer dizer, que Norte e Nordeste, que é realmente o foco desse ponto de troca de tráfego aí. Esse é o esquema do projeto do OpenCDN, né? Quer dizer, que a gente monta uma infraestrutura local para que, a convite, as CDNs coloquem seus servidores nessa estrutura. E dessa maneira, a gente tem atuado em Salvador e estamos começando essa estrutura em Manaus. Aqui é a estrutura de cabo submarino, né? Cabo submarino aí a gente tem 3 principais pontos de chegada no Brasil, né? Fortaleza, Rio de Janeiro e São Paulo. Um único cabo submarino se conecta na Bahia, mas a grande concentração se dá em Fortaleza, Rio de Janeiro e São Paulo. Aqui, eu só queria colocar aqui, né, pessoal, que para nós foi importante essa mudança de perfil, né, para podermos passar pela pandemia, tá? Porque antes dos principais conteúdos de streaming, né, em 2012, o pico se dava no horário da tarde, no horário comercial. Então, essa barra preta aí, que está indicando a parte do horário comercial aí. Só que em 2013, esse pico que está em amarelo aí passa a ser no período noturno. Isso faz com que a importância se volte mais para a internet residencial do que para a internet comercial. Quer dizer, que a banda mais utilizada passa a ser a residencial do que na comercial. E o final de semana ocorre a mesma coisa, tá? Que era um tráfego baixíssimo no final de semana e passa a suplantar os dias da semana. Então, o que aconteceu durante a Covid, né? O tráfego agregado, né, que estava em 9 terabits por segundo, no início do ano, em 18 de março chega a 10 terabits no agregado total. Uma semana depois chega a 11 terabits por segundo. Tá? E em julho, o ponto de troca de São Paulo passa a marca histórica de 9,18 e é considerado o maior ponto de troca de tráfego do mundo. Tá? E em 20 de agosto ele chega a suplantar o 10 terabits por segundo, o primeiro ponto de troca de tráfego a ultrapassar essa marca. E nesse ínter aí, em agosto, 19 de agosto, acabou o estoque dos endereços IP versão 4 na América Latina. E a gente já temos participantes no ponto de troca de tráfego só com IPv6. Não tem, tem um participante que não tem IPv4 e está participando do ponto de troca de tráfego de São Paulo. Tá, nesse período aí, a parte de registro de domínio atinge 4,45 milhões de domínios. A quantidade de sistemas autônomos aí suplanta 8,4 mil, digamos, provedores, empresas, universidades e governo, né, os titulares aí, né? São mais de 8.600 sistemas autônomos, alocações, né? E a gente representa 71% dos sistemas autônomos na América Latina. 63% IPv4, 73% IPv6. Importante também nesse período, né, ressaltar que a gente passa a ser o número 1, digamos, número 1 no mundo, né, relacionado à tolerância à falha. Tá? Quer dizer, que se um sistema autônomo falha, o país não é impactado. Quer dizer, que a gente estava em segundo lugar o ano passado, e esse ano aqui, durante a pandemia, a gente passa a ser o número 1 do mundo em termos de tolerância à falha. Quer dizer que, então, a gente está bem nesse quesito aí, principalmente pela quantidade de sistemas autônomos que a gente tem, principalmente pelos grandes players que estão presentes aqui no Brasil. Isso faz com que a gente tenha uma internet bastante robusta. Aqui um cenário de como evoluiu aí o tráfego de São Paulo, né, durante a pandemia. Né? Antes da pandemia, como é que estava? Né? Tínhamos menos de 7 terabits por segundo. Aí, no início de mês de março, já na pandemia, mas sem isolamento social, atinge 7 terabits por segundo. Aí, quando tem a primeira semana do isolamento social, alcança 8,5 terabits por segundo. Na semana seguinte, esse tráfego cai por causa da redução da qualidade do streaming e passa a crescer paulatinamente e alcança níveis históricos aí daqueles que a gente sabe que acabou atingindo os 10 terabits por segundo. E continua crescendo. Tá? A gente também fez um estudo na parte de medição de qualidade, né? Como é que estava a qualidade da internet no Brasil, como é que foi a influência da Covid na qualidade da internet no Brasil. O que a gente usou aí foram as ferramentas de medições que a gente tem, né? Software, aplicativos web, aplicativos mobiles, né? Softwares aí que você instala também em sistemas operacionais Windows e iOS, né? E temos também software embarcado, né? Porque isso aqui também é uma das coisas aí que a gente está conversando aí com o professor Marcelo Zufo aí para também embarcar aí nos caninos loucos aí para poder termos também as medições nos sistemas embarcados. A gente vê aqui, né, o que aconteceu em termos de tráfego no X, né? Quer dizer que com a subida, com a redução de tráfego aí, de redução de qualidade, tá? E com a sua retomada de crescimento posterior a isso, que deu tempo para as principais redes se estruturarem. A quantidade de medições nesse período subiu. Quando a quantidade de medições sobe, significa que o usuário encontra problemas. Isso é indicação de que a qualidade percebida não estava tão boa assim. Tá? Então, o que eu posso dizer é que o que a gente constatou é que as redes que estavam boas conseguiram muito bem se adequar a esse período, né, essa elevação de tráfego, caso da região sul e sudeste, mas as regiões nordeste e centro-oeste, como assim, tiveram um pouco de impacto, já tinham antes, né? Mas a região norte, para nós, aí, é a mais preocupante, aí, que a infraestrutura, tanto antes quanto depois, ela não é muito boa, né? Ela precisa ser trabalhada aí. Isso é uma das coisas que a gente está tentando atingir com o projeto do OpenCDN, levando o conteúdo lá para Manaus para podermos tentar fazer uma melhoria nesse quesito da qualidade na região norte. Bem, usando esses medidores aí, quer dizer que a gente tem uma parceria com o Ministério da Educação no programa Inovação e Educação Conectada, e esse daqui é o mapa com as escolas sendo monitoradas. Então, a gente tem dados relativos às medições, né? Então, eu tenho esse mapa aqui, está mostrando aqui como é que está a velocidade do TCP download em megabits por segundo, né? E você pode selecionar regiões, você pode selecionar um monte de informações aí, né? Para você poder fazer análise, né? E ver como é que estão as escolas em cada uma das regiões, fazer comparações, aí, escolhendo até três regiões aí para você poder ver como é que tá as escolas. E a gente juntou também as informações que o MEC tem relacionadas às escolas para podermos ter uma visibilidade melhor de que tipo de infraestrutura a escola necessita nos mais diversos locais aí do Brasil. A gente tem mais de 30 mil escolas nesse sistema já sendo monitorado online. Tá? A ideia é crescer e alcançar aí algo na faixa de 200 mil. Dentro do programa por internet mais segura, né? Quer dizer que naquele ponto, né? Que é uma preocupação aí, principalmente no quesito aí da internet das coisas, né? Porque são esperados aí que mais de 20 bilhões sejam conectados à internet esse ano, tá? E segundo a Cisco, até 2030 estarão conectados mais de 500 bilhões de dispositivos. Então, será que a nossa rede está preparada para essa tecnologia da internet das coisas? Como estamos em relação à segurança, né? Então, preocupado com o futuro da nossa internet, né? Sabendo que a internet atual, né, que é vamos dizer assim, essa rede formada da união das várias redes, né, por isso que é chamado de redes, né, são mais de 60 mil sistemas autônomos interligados, né, e se comunicando através de um protocolo de roteamento chamado BGP, que funciona na base de cooperação e confiança. E devido a isso, né, quer dizer, que o fato de não ter validação dos dados, né, não há um dia em que não ocorra incidente de segurança na internet mundial. Tá, então, a gente lançou esse programa para uma internet mais segura, né? Vocês podem ver o site aí, bcp.nic.br e MySeg, né? Para poder endereçar esses problemas relacionados à segurança. Então, a gente tem levantado quais são os principais problemas de segurança na infraestrutura da internet, o ataque de DDoS, sistemas mal configurados que permitem amplificação, tem sequestro de prefixo ocorrendo de montão, vazamento de rotas, ataques de força bruta. Então, a gente tem atuado em relação aos nossos levantamentos, né? E temos atuado junto com as operadoras e provedores para que a gente possa melhorar a qualidade da internet brasileira. Tá? E a gente tem feito bastante palestras, cursos, e em cima dos indicadores de segurança, a gente tem atuado junto aos operadores e provedores. E na parte de troca de tráfego, a gente começou a aplicar os filtros aí para podermos ter uma internet melhor quando os anúncios não são bem feitos. Então, aqui são levantamentos que o CERT faz, né, sobre os protocolos, né, porque permite amplificação de tráfego. Tá? Então, tem na parte de DNS, SNMP, NTP, SSDP, Ubiquiti. Então, esses aqui são alguns dos protocolos que permitem amplificação e quantas notificações a gente tem feito aí junto com os sistemas autônomos aí, dizendo que está mal configurado. E, desde o nosso início do programa, a gente conseguiu uma redução significativa aí, né, de 62% do total de serviço mal configurado desde o início do programa. Na parte de IPv6, né, pessoal, é importante frisar que a internet continua crescendo, IPv4 terminou, então agora provedores que estiverem nascendo aí vão ter que nascer somente com IPv6, não vai ter IPv4, a não ser que tenha recuperação de endereçamento IPv4 e esteja redistribuído, mas esse exemplo aí de provedores que só tem IPv6 vai ser uma normal daqui para frente. Tá? Então, a gente tem aí algo como 4,8 bilhões de usuários de internet no mundo, né? Isso corresponde a 62% da população, crescimento de mais de 1.200% desde 2000, né? No Brasil, 28% dos domicílios não possuem acesso à internet, então o potencial de crescimento é enorme, e a gente está com o IPv4 esgotado aí. Então, o que fazer, pessoal? A gente precisa crescer IPv6. Então, pensando aí no crescimento da internet, a gente tem que incentivar o uso e a adoção de IPv6. Tá? Hoje em dia, quer dizer que pela falta de endereçamento IPv4, o pessoal acaba usando essas soluções Carrier Grade NAT, tá? para poder fazer com que um endereço IPv4 atenda a vários usuários simultaneamente. Então, você tem um problema de compartilhamento de endereçamento IPv4 por vários usuários aí. Então, fica difícil identificar o usuário e também a parte dos aplicativos, principalmente a parte de games, tem sofrido com isso, tá? Porque ele usa o conceito de porta, né? Para poder endereçar esse compartilhamento. Então, um IPv4 diferenciado pelo número de portas é compartilhado com vários usuários. Bem, no mundo aí, a adoção do IPv6 está crescendo, tem mais de 30%, nos Estados Unidos 41%, Índia 47%, Bélgica 54% e o Brasil na faixa aí dos 35%. Ok, pessoal? Então, o Brasil está pouco acima da média, tá? Então, isso aqui é um outro dado aqui que vem da parte da Cisco, né? E apresenta na parte dos usuários 35%, mas na parte da parte de infraestrutura, né, a gente já tem algo como 50%, aí, mais de 50% aí já com IPv6. Essa parte dos usuários aqui, a gente aí alcança aí 35%, né, pessoal? O Brasil aí, segundo algumas outras fontes, essa fonte aqui, Facebook, também indica acima dos 30%. Então, vocês podem visualizar aqui também a Camai, aqui também acaba também indicando aí 36%, quer dizer que então os números aí de forma generalizada indicam adoção superior a 30% aqui no Brasil. Tá? A parte de hospedagem, data centers, estão todos ok em relação a IPv6, todo mundo atuando na parte de IPv6, então os principais conteúdos já têm IPv6, então não vai ser por causa da parte dos data centers e hospedagem que os serviços não serão disponibilizados. Na parte de ponto de troca de tráfego de São Paulo, aí, já estamos chegando aí a 900 gigabits por segundo de tráfego trocado em IPv6, tá? E esse número tende a crescer, tá? Algumas redes aqui, em amarelo é o Brasil, tá, pessoal? E essa daqui, em azul aí, é como que a Telefônica está, né? A Telefônica tem tem mais de 80% da sua rede em IPv6. Aqui a rede da Claro, mais de 60%. Vocês podem visitar aqui o nosso site para testar se a sua rede tem IPv6, se o seu acesso tem IPv6. Então, você pode testar aí os sites também. Então, a gente tem bastante ferramenta no portal ipv6.br, tá? E temos também bastante conteúdo, né? A gente tem feito curso, né? Principalmente a parte de treinamento, né? Quer dizer, que isso que foi endereçado pelo Gabriel, aí, essa pergunta em relação ao DOA, a parte de treinamento, ela é muito importante, tá? Para que as pessoas entendam e as pessoas estejam familiarizadas com a parte de curso, tá? Então, a gente também disponibilizou livros, né? Para podermos ter laboratórios práticos aí para poder treinar não só os técnicos que atuam na parte de rede, como também os alunos novos aí que estão ingressando no mercado. A gente tem atuado bastante nessa parte de treinamento aí, e é importante frisar, né, porque todas as grandes operadoras que hoje já estão com as suas redes acima de 70% conectadas aí na IPv6, né, todas elas tiveram cursos com a gente, tá? A gente fez curso mão na massa mesmo e treinamos os técnicos dessas principais operadoras a configurarem sua rede IPv6. Isso surtiu efeito, tá? Então acho que estamos no bom caminho. E a gente está fazendo isso aí paulatinamente com os provedores regionais, que também tem os seus problemas, e a gente está treinando os seus técnicos. Então, é o que eu tinha para falar aqui em 30 minutos. Eu vou...
Milton, muito obrigado. Fica um pouquinho. Eu não sei se, por acaso, o Robert Kahn e o Sam estão aqui ainda. De repente, eles têm alguma pergunta. E não sei, da plateia, até o momento, não tinha nenhuma pergunta. Nós realmente já passamos a
Te
hora, mas
enviei.
Como?
Enviei para você, Gabriel, a pergunta.
Tá bom. Tem uma pergunta do Ediraldo Bernardi. A pergunta é: o tráfego de internet do Brasil utiliza apenas cabos, fibra ótica, submarina, subterrânea e aérea, não utiliza satélites?
Assim, utiliza satélite sim, tá? Quer dizer, que tem provedores que atuam no mercado nacional utilizando satélite, e vamos dizer assim, uma das empresas aí norte-americana está atuando aqui no mercado nacional, tem uma clientela já bastante considerável, principalmente porque o Brasil carece exatamente de soluções, né, para poder endereçar certas localidades que são difíceis de você abordar com cabos de fibra ótica ou se não qualquer outra tecnologia. Hoje em dia, né, quer dizer que eu falo dos provedores regionais, eles têm atuado mais com instalação de cabo de fibra ótica e rádio, né, rádio para poder fazer o transporte onde que a fibra não se justifica, a distância é muito grande para atender poucos clientes. Tá, então vou dizer que no mercado brasileiro, de fato, usa satélite sim, tá?
I have a quick question about what's the status of 5G communication?
Sobre a comunicação 5G, né, quer dizer que as empresas ainda estão se preparando, né, quer dizer que a gente tem notícias aí dessas grandes operadoras preparando as suas redes, né, principalmente porque as suas redes foram feitas com o crescimento natural, vamos dizer assim, e foi crescendo, fazendo várias camadas, né? E como que o 5G ele vai precisar de uma rede melhor estruturada com menos hopes dentro das suas próprias infraestruturas, a gente tem conhecimento de operadoras que estão fazendo o seu dever de casa dentro das suas redes para poder fazer com que o core da rede ela não tenha vários steps até chegar à parte de acesso da rede. Ok? Então, com isso, já preparando a rede para que tenha uma latência menor e também, vamos dizer assim, já estão adequando seus sistemas, né, para poder ter orquestração. Então, ainda, vamos dizer assim, alguns trials, né, sendo feito em cima da tecnologia existente aí de 4G e em cima da rede que eles têm hoje, tá? Então, vamos dizer assim, o leilão vai acabar acontecendo só o ano que vem, o leilão das frequências que o Marcelo Zufo citou, né? Então, a agência reguladora aqui do Brasil vai fazer o leilão o ano que vem, vai ser o maior leilão do espectro de frequência. Isso é bastante esperado, né? E existe bastante debate, bastante contribuições, né, para que esse espectro seja bem utilizado e uma boa regulamentação fará com que vários players possam utilizar esse espectro de frequência e tentar endereçar esse grande número de usuários que ainda não estão conectados na internet. Respondi?
Aparentemente, não temos mais respostas. Sam, você quer complementar alguma coisa? Então, acho que agradeço o Milton.
Yeah, it's very good. Thank you.
Espero que nós tenhamos tido uma boa plateia, porque realmente foi muito boa, tanto a primeira parte como agora o Milton. Acho que em uma nós mostramos um caminho que acho que é meio obrigatório para o futuro, de pensarmos no crescimento e nessa interoperabilidade e nessa redução de endereços, e no segundo mostrando como o Brasil está bem preparado nisso e vai continuar. Então, acho que esse papel que nós estamos fazendo de debater essa proposta, que já está em uso do DOA, é muito importante. O NIC-BR já há anos tem participado, já teve um representante lá num dos eventos coordenados pelo SAM. Então, vamos seguir com isso. Convido a todos para a parte da tarde de hoje, que teremos uma discussão sobre também coisas ligadas aqui de alguma maneira, blockchain, seus usos, moedas. Não vai dar para falarmos em muita profundidade, porque o tempo é curto e são temas importantes, mas moedas virtuais, blockchain e coisa. E estamos trazendo gente boa, gente que entende do assunto, e vamos também fazer o lançamento do desafio IoT, que nós estamos chamando 2020, 2021, porque 2020 nós não conseguimos fazer, seria este ano, com a pandemia, não conseguimos fazer. O Bob está entrando, quer falar? Please, Bob, go ahead. Bob, if you have some point or some question, feel free to talk.
No, I just saw accidentally I hit the unmute button, but no, it's very interesting. It's clearly Brazil is a major player, so very interesting to see, and nice to see about the NIC-BR and all the good work it continues to do. So thank you.
And I hope that we will have many chances to be interacting. And NIC-BR, it's an important player for us in everything. Estava dizendo que para amanhã, hoje temos essas coisas na parte da tarde, e amanhã é o dia dedicado à segurança. Na parte da manhã, vamos estar falando mais da segurança pessoal, num certo sentido, mas e na parte da tarde. E temos gente do NIC-BR falando também, na parte da manhã, e estamos trazendo vários especialistas do assunto. Aí segurança é um assunto mais pesado, mas por isso reservamos um dia inteiro. Então, agradeço a todos e até a tarde hoje. Mais uma vez, Bob, Sam e Milton, muito obrigado pela presença e pela colaboração.